So the other day I made a short video going over some troubleshooting I was going through with my DrillDaddy design, following getting a 1-star review on Etsy. And in that video, I, kind of tested the DrillDaddy and was trying to see, is it really as fragile as this customer was saying that it is. And I concluded in that video that, well, it was probably just a user error. Maybe I can tweak the design and make it a little bit stronger. Yeah, I was like 100% wrong on that. It was not a user error at all. It was absolutely 100% an oversight on my end. Okay, so I took another look at my inventory and I realized a very critical problem. Listen to this. You don't want that as a tool. Nobody wants that. I can tear this apart with my hands. Most of the ones that I've printed, there's no way that I'd be able to. So I needed to try and figure out, like, no wonder that guy's broke. The entire bolt, I have a whole pile of ones I've broken. The entire bolt was being held in place by four very, very small infills. And I'm looking at this and I'm like, that is not what my infill is supposed to look like. So ultimately though, I think I figured out where I made this mistake, because I don't usually go in and change printer settings. Once you have a good print, you just hit print again on the printer. And I realized I was working on 2 different projects at once. I was working on improving the DrillDaddy design, and I was helping one of my kids with a science fair project. And the science fair project, we made a magnet train, right? So you turn it one way, it sticks. Turn it the other way, and it floats above the tracks. So obviously this was like 5% infill, because it's supposed to be a really lightweight train that floats on the tracks, so the kid could, demonstrate magnets. And so I got that printing, and then I went in and I was making some adjustments to the DrillDaddy design. So I brought the new design into my slicer and just absent-mindedly used the settings that I had used on the magnet train, which of course resulted in printing a product with a 5% infill that should never be intended to be used as a tool. And so just this absent-minded mistake, I had sent out, I don't even know how many, just crappy designs to people on Etsy. And so obviously I've already sent them messages, like, hey, I will either refund you or send you a new one, whatever you want. Can't do anything about the 1-star reviews, but I can't be sending people this. Like, look at this. Like, that's not a tool. That's garbage. And so I want to show real quick what this looks like in the slicer, and how you can kind of see the impact that the infill can have on the structural integrity of this design. So right here I have a plate of DrillDaddies that supposedly would be ready to print, right? So at a glance, these look just like any other print, but if you go down through the layers, you can see right off the bat that there is no structural support going down all the way through the eye holes, through the mouth. Zoom back out. And that if I go further down into the interior of the part, this is where we see that there is only 4 incredibly thin walls that are holding what's supposed to manage the torque of a drill. So, obviously this is going to fail when you print it. Now, the first batch that I had sent out had an infill of 20%, which is what I use on my personal drill when I was first testing this design, and I went through with all my iterations. I'll show you what this looks like on the slicer. So at 20%, you can see that this is already a drastic improvement. There's not really, you know, if you're pushing around the body of the part, there's nowhere that your thumbs are going to push through the any of the top or bottom walls. The nut is being held in place by, you know, quite a few different locations. And then when you look up through the zoom out a little bit, when you look up through the rest of the print, you know, that grid carries up into the eyes and the mouth and actually provides a bit of support there. So while I'm in here though, you know, I'm realizing some people realistically are probably more rough with their tools than I am. Maybe they have stronger drills. And so for this batch that I'm sending out to people as replacements and then hopefully future orders, I'm going to do a couple things. I'm going to go from 20% infill. Go here. I'm actually going to increase this, I think, to 60. You can see how much denser that is in the eyes. So that would make me feel a lot more confident with, you know, I'm not really too worried about the eyes and the mouth breaking. I mean, it's just holding a sponge, but you can see here how much better this is at holding in that nut. It did increase my print time by about an hour, but I mean, I'm willing to eat that cost. And then I want to change the walls. I'm going to increase this to 3 layers. The thickness of the walls actually does a lot for the integrity of a design. Some people actually argue that the wall thickness does more than the infill. I mean, the reality is it's probably a mix of the two. So ultimately, this is what we're going to end up with as the interior. You know, I've added about an hour to my print, but you can see that this is going to be a lot stronger. Holding around that nut and then going up through the eyes, there is a lot holding onto it, and then we have 3 wall layers on all of the features. Overall, this is just going to be a lot more robust of a design, more robust than the one I've been using personally, so I'll probably snag one of these for my personal stash. But this is actually what I have printing. I've got my printer case right here, and I'm just going to be printing these all weekend, sending out replacements. Unfortunately, a lot of the ones that I've sent out actually haven't even been delivered yet, but all of those customers already have an email in their inbox stating, hey, your product is probably defective, just reach out to me, because I don't want you to have that. I've already had a guy, he responded pretty quickly, so I'm getting him a replacement. So yeah, here in 5 hours, I'm gonna do a quick strength test comparison so we can see how that improves it. Okay, so we're some ways into the print right now. You can see this is what the 60% infill looks like on the interior part versus the 5% that I accidentally sent out. So already this is a far superior print. So we'll let this finish. Okay, so I have 4 of the improved print profile ready to go. The very first thing is, 1, the print just looks fantastic. Look at that, there's not a single blemish, so that looks good. The eyes and the mouth, I can pull the mouth until my fingers turn white. That's a good sign. Eyes are the same way. Okay, that is fantastic. Pushing on it, right by the microphone, nothing is cracking. Okay, that is solid. I'm going to pop the hardware in, and we'll see about just kind of doing that on the drill. I'm not going to bother with the Loctite because I don't need this to stay in permanently yet. And then all I have to do is just make sure it doesn't crack the way the other ones did. Okay. That, let me tighten that up. That's a good sign. Yeah. I don't know if you can see that. Let's do this. Let's see if I can get it to break. Nope, that's not going anywhere. I'm gonna call that a win. Ha ha ha. Okay. I can send out replacements now, and I can actually ship out a solid quality product. That's a good feeling. I should have done 60% infill this whole time. I'm really happy about that. Success.